All right, solving rational equations. Solving rational equations, well, of course, we're talking about equations that have fractions in them. We've kind of already seen this already when we were doing linear equations. So let's take a look at how we handled this in the past when we had fractions. Like 2/3 x plus 1/4 equals, I don't know, 5/6. So this is just a linear equation. So what we would do, of course, is clear grouping symbols, clear fractions or decimals. We'd find the least common denominator, which in this case, our least common denominator is what, 12. We multiply everything by the least common denominator. 12 times 1/4. That should get rid of all of these fractions. Let's see, 3 goes into 12 4 times. 4 times 2 is 8. Those are x's. 4 goes into 12 3 times. 3 times 1 is 3. 6 goes into 12 twice. 2 times 5 is 10. Then it was still a linear equation, but a lot easier to deal with. So we'd have 8x is equal to 7, and we just solve whatever's left over. All right, well, we're going to do basically the same thing when we're dealing with rational equations, except for there's an extra step we got to throw in to do this. So let's come over here like always and run through the steps that we just did. The first thing we did here was find our least common denominator. Well, when we have rational expressions, that's a little bit more difficult than just looking at it. So, so far to find the least common denominator, we factor all the denominators. Factor all the denominators to 2. Then we can find our LCD, just like we have in the past. Now, step 3 that we're doing over here, we actually didn't do here because this was a simpler equation. That's just a linear equation. So what we need to do here is some side work. Set the LCD equal to 0 and solve. These values cannot be solutions. And we'll see why in just a second. All right, so once we found our LCD, we're going to multiply through by the LCD. Once you do that, that'll clear your fraction. So solve whatever's left. It could be a linear equation. It could be a polynomial equation that we have to factor. But solve whatever's left over. And then the last thing we need to do, it's not really a step, so to speak. You just got to ask yourself, can these values be solutions? Again, we'll see what that means in a second. All right, so let's go over here and take a look at a more traditional looking rational equation. Again, remember when we're thinking rational expressions, most of the time we're thinking fractions with variables in the denominator. So it might be 4 over x plus 5 equals 3 over x minus 2. Something like this. Okay, so here we have an equation, we've got an equal sign, and rational because we have these fractions with variables in the denominator. So to solve this, following our step 1 is to factor all the denominators. Well, we can't factor either one of those anymore, so we should be able to find our LCD. Just like when we were adding fractions from a couple of sections ago, you take each factor the most times it occurs in any denominator. So our least common denominator is x plus 5, x minus 2. Now here's where the side work comes into play. Take this, set this equal to 0, and solve. This is our side work. Now the good news here is this is already factored, so this should be a very easy step for you to do. Just set each factor equal to 0 and solve. So we get 2 answers here. X is equal to -5 and x is equal to 2. Now I said that these values can't be solutions. Remember what our definition of a solution is. When we plug it back into the original, it gives us a true statement. However, if we try to plug either one of these values in here, let's look at the -5. Notice if I try to plug the -5 in here for this x, that gives me a 0 in the denominator. We're not allowed to have that, which means -5 can't be a solution. Same thing for the 2, right? It's fine here, but it would make that denominator 0. So the easiest way to do this so you kind of remember, somewhere around your problem, I'm actually going to get that out of the way for right now. Somewhere around your problem, do something like this. X cannot be -5, x cannot be 2. just to kind of remind ourselves at the end. All right, step 4, this is the step that generally takes a lot of writing. We're going to multiply every term by our least common denominator. Now, since it's a lot of writing, you guys get lazy and want to skip this step. Do not skip this step. Write it out. X plus 5, x minus 2, 3 over x minus 2. All right, let's see. Over here, the x minus 5's cancel. I got to do 4 times x minus 2. Again, since we have to distribute, we're going to write that out as one more step. Over here, the x minus 2's cancel. I have 3 times x plus 5. Again, I have to distribute, so I'm going to wait one more step. Now, step 5 says solve. What type of equation is this? Well, it looks like it's linear, so following my steps for a linear equation, we're going to clear our grouping symbols. That's what, minus 8, 3x plus 15. Get all of our x's on one side, get everything else to the other side, and then divide. So we get x is 23. Now before I put a box around that and say that that is my answer, is that allowed to be an answer? Or can that be a solution? Well, yeah, because it's not one of the values that we threw away. So we're going to say that that is our answer. Okay, so a little bit of longer problem. Factor all the denominators to find the LCD. Go over to the side, set that equal to 0 and solve. That's the values that your answers can't be. Then multiply every term by the least common denominator. That should clear your fractions. Solve whatever's left over and check to see if it's allowed to be a solution. All right, let me give you guys one of these to try, maybe a little bit longer. Let's see. Let's say if I gave you okay, 6 over x plus 2 minus 10 over x minus 3 equals 7x over x squared minus x minus 6. All right, this is a little bit longer than the last one, but hit pause, see how well you can do. All right, if you're back, let's see how we did. So first up, factor all the denominators so we can find our least common denominator. Well, the first one won't factor. Second denominator won't factor, but this one over here will factor. That's going to be what, x minus 3, x plus 2. So now we should be able to figure out what our least common denominator is. Well, it's x minus 3, x plus 2. Right? The most times an x plus 2 occurs is once. Here it happens once, 0 and once. X minus 3's only occur once, or the most is once, because it's 0, once, and once. So there's our least common denominator. Again, for our side work, set this equal to 0 and solve. Set each factor equal to 0. So we get, again, two values that we're not allowed to have as solutions. In this case, a positive 3 and a negative 2. So somewhere around your problem, say x cannot be 3, x cannot be negative 2. All right, so for the long step, now we're going to take our least common denominator and multiply every term by that least common denominator. So that's x minus 3, x plus 2, 6 over x plus 2. X minus 3, x plus 2, 10 over x minus 3. X minus 3, x plus 2. X minus 3, x plus 2. All right, the longer step, make sure you're writing it out though. All right, so let's see, if we reduce here, the x plus 2 is reduced. I have 6 times x minus 3. I have to distribute, so I'm going to wait one more step. Minus the x minus 3's cancel. I have to do the 10 times the x plus 2. Again, I have to distribute, so I'm going to wait one more step. And here, all that cancels with all that. The only thing we have left on the right-hand side is 7x. All right, now we need to solve whatever's left over. In this case, let's see. It looks like a linear equation, so let's clear our grouping symbols. Minus 18 minus 10x minus 20 is equal to 7x. So combining like terms this way. Negative 4x minus 38 is equal to 7x. Let's move the 4x over there. So I get negative 38 is 11x and divide. So we get x is equal to negative 38 elevenths. All right, so before I put a box around that and say that that is my answer, is that allowed to be an answer? Well, yeah, the only thing that weren't allowed was a 3 and a negative 2. So we go ahead and put a box around that and say that is our answer. All right, so you notice it is a little bit of a longer problem, so make sure you're going step by step to make sure that you're not losing your place. Now let's try one more of these. Let's see here. See if I gave you something like this, about x squared over x minus 4. Maybe a little bit easier, but go. Hit pause, see if you can solve this. All right, so let's see how you did. Step 1, factor all the denominators. Well, that's done. This one's pretty easy to see. There are least common denominators, just an x minus 4. Go over to the side, set this equal to 0 and solve, and of course that's just x equals 4. So we know no matter what, x cannot equal 4. Then we multiply through by our least common denominator. Let's see, on the left-hand side, that reduces, and all we have is x squared equal, let's see, that reduces over here, 16. All right, so we cleared all of our fractions. The power is higher than 1, so it's not linear, so we move everything to one side and try to factor. That's the difference of squares, so that'll factor to x plus 4, x minus 4. Two things multiplied together and equaling 0. One of those factors has to be a 0. So we get two possible answers, negative 4 and positive 4. Now before I put a box around these and say that these are my answers, are those allowed to be answers? Well, the 4 is not allowed to be an answer, so we got to throw that one away. So our only answer here is x equals negative 4. Now if we would have to throw away all of our possible answers, then we wouldn't have any solutions, so of course you'd answer no solution. All right, that's solving rational expressions. Make sure you're following the steps so you don't get lost.